what I'm going to do is I'm going to teach you an online tool where you can create a schematic of different circuits and you can see how it will turn out in a PCB. So for that I'm going to go to a website called as EasyEDA. So when you go, open the first link, and you can you'll be learning in this page. In this page you can see here, this is where you will log in, and I suggest you to use our KPRIET email ID so that you'll get free access. Otherwise it's free as well. You can use it either on online or you can download and use. I prefer online, so I'm going to use online. So when I press, I get this two option. Pro edition is quite good, but still to learn the basics, and here I have mentioned for students, teachers and creators, it's best to use the standard edition. I'm going to go ahead with standard edition, and this standard edition I have already opened in another page, so I'll be skipping there. But before that, so here we have two modes. One is simulation mode, the other one is standard mode. Right now we are going to do the standard mode. So this is how the interface will be. You'll have to go to new project. When you click new project, it will create a new project, and the new project will be like this. So there you'll have to go right, and here you'll have to press schematic. So after pressing schematic, you will get something like this, right? So here, this is the place where you do the schematics. This is the entire web page where you can design things, and you have a lot of tools available. To start with, the main important tool that we are going to uh, use, or the one that we will be needing, is this common library. So when you press common library, you can see the items that we commonly use, right? So now what I'm going to do is I'm going to simulate, not simulate, I'm going to create a schematic of a simple what do you say, let's say take an inverting amplifier, right? So for that we need a resistor. So clicking this resistor here, and when I bring, or when I move the cursor on the workspace, the resistor will come. You don't have to drag, it will automatically come. You have to press once, it will be placed there. Another resistor we need, so I'm going to place it somewhere here, right? So this resistor will keep on moving along with the cursor. If you don't want, you'll have to press escape button. Now I have pressed escape button and it is gone. Now what else we need? We need IC741. See, we have an option here to search, so we'll search IC741. It's not available, so you don't have to worry. We have another library. So if you press that, you will be taken to a very big repository where you can find almost every element. So you can type as LM741. Okay, I'm typing here LM741, not IC741. The reason is because IC741, there are different variations, different packages, right? Even now, see, when I click the first one, you can see the symbol here, and this is the model that will be. But I don't want that. I need this model, the dip model, right? And there are also another versions which will be very comfortable for us to work with. Uh, let's try to find. Okay, so we'll search through the entire database. Look here, we have got something which we have already studied in one of our subjects, right? So there are different libraries. So I have chosen LCSC. There are JL, CPCB, system, and user contributed model also. Now here I have used LCSC. In that I have chosen this particular model, which is DIP8. So you can see how it will look like in real life. And this is PCB schematic, and this is normal schematic. This is something which we have already studied. So I'm going to go ahead with this. So after clicking this, I have to press this place button. So if I do what, I can see the symbol moving along. Now press once again and it is fixed here. Now what else we need? We have two resistors, then the main IC741. Now we need ground. So I'm going to take one ground here, and yes, one ground is sufficient. Then I'm going to take 5 voltage. So to select 5 voltage, press this arrow, you can see 5 voltage here. Take it 5 voltage somewhere here, and we also need minus 5 voltage. Take it, put here. Okay, so this is plus 5 voltage. If I don't want, I have to simply click and delete. Minus 5 voltage, minus 5 voltage, right? So usually we use plus 12 voltage, right, in our experiment, so we can change that as well. 12 here also, you can have minus 5 or minus 12, or if you want the simple the signal to be generated only in the positive direction, then you can make this as 0 volt also, right? Now we have got almost everything. Only thing that is left is the connection. So to connect, we need to press W. When I press W, the wire will automatically come, right? Or rather than pressing W, you can see the wiring tool here. You can use this as well, right? So let's start wiring from here to here, and from here to pin number 2. And then we need a feedback. So from the output, I'm going to take a feedback and put it somewhere here, right? And from 3, I'm going to directly connect it to the or let's have something like this, and we will take the ground, take the entire ground and bring it a little closer so that the diagram will look a little neat. Pressing W and choosing the wire. I've connected the wire. Now minus 4, 4 is connected to minus voltage, which is minus 12, and 7 is connected to positive 12 voltage, right? So now our connection is all done. We don't have to worry about pin number 1, 8 and 5. 1 and 5 are for offset, and 8 is usually not connected. Offset is when we find if there is any offset voltage, but right now we are not going to worry about it. The thing is, we need to understand how to create a schematic. So this is sufficient. We have two resistors connect. So this is where we will be giving our input. So I have not included any input here. The reason is because we are going to create a PCB schematic. Even if you create a input, that cannot be reflected in PCB. So I have not included any input here. Similarly, no output here, which we can do in the PCB part, right? So other than that, the schematic is done. Now to convert, we have to convert this into PCB. To do that, you have to go to design, convert schematic to PCB. If I click this, it will ask me to find if there are any unchecked nets. You can press it, and it will show you if there are any error. Mostly there won't be any error, so we can proceed. To save before proceeding. Saved, convert, right? So after that, it will ask how much the small box size should be. It is in mm. Then how many layers, what kind of board you want. You can have rectangular, circular, round, rectangular, and you can specify the size. So yes, the size looks something like this, right? So this is the PCB layout. Now whatever you put inside this colored bars will be the PCB. So to make it look little simple, I'm going to rotate this. To rotate, click the object and press R. So pressed R, right? Let's press one more time, and let me bring this to this side. I'll bring this here and here. See, this is completely up to you. You have the freedom. You can do whatever you want. So this is usually pin number 2. So you'll have your input somewhere here, right? And your output is here, right? So now what we have to do is we have to create the connection here also. There we created schematic connection. Here we will be connecting the PCB connection, right? So again, you choose wire, connect. So when I do this, this is top layer. You can see here, this is top layer. If I want to do in the bottom layer is on the other side of the PC, right? So we can create a double layer also. Here we'll stop with this, and see, this connection is done. When I give connection here, this region could get affected. So I'm going to bring it to lower, and then here. right? So if there are so many things, you can also consider using auto route. So when I do auto route, it has created route, right? So when I do this routing, see, I have not used what do you say, 90-degree turn, right? When I use 90-degree turn at that angle, it will create some kind of distortion. So they always use a slanting change in direction, right? So that is what preferred, but here it is not done because of the space constraint, right? So this is something that you have to keep in mind. Now I told that we'll be giving input at pin number 2, right? So to do that, we can use this. We call that as pad. Put here, and we need another pad here to give output. So how to give the output? Again, press the wire from here to here, right? And then from here, right? So see, now we have encountered a problem. This cannot be accessed. So what can we do? What we can do is we can okay, bring it little something. We can do something like this, and now we can continue with this. We take and put it here, right? So now this is okay, right? So we have connected all the wires. If you need, we can also consider doing a rerouting. So it is done. 0 failed, all done. Okay, it has removed it because there is no trace, so we can do it again. And another connection, right? So we are done, right? After completing, we can also see the 3D view of how our circuit will look. So if I press 3D, so this is how it will look. We allow IC741, and this is where you give your input. We soldered the input cable and the output here. You can connect this to the DSO from to here. I mean, at this point you will connect the function generator or any AC input here. I mean AC signal. Here you get the output, right? And these are the two resistors that we used in the circuit. Right. And we also have to consider the ground. This other terminal will go to the uh, so this other terminal actually, okay, so this is the part where we have to connect the input. I have connected it directly to the pin, so it should actually go through this part, right? So that's a mistake that I've made, so I'm going to rectify it. Let's do it. Should be removed, this wiring should be removed. Yeah, you can go back to the top. You can come somewhere here. Let me do rerouting. Right. So now it's fine. So the input should be somewhere here, right? I made a mistake earlier. So here, from here, you can connect here. And from here, you can connect here, right? Fine. Now this will be okay. And here also the line is crossed like this, but then you don't have any intersection because wait, you will see in the 3D so that you'll understand better. See, the line is going here, but it's not creating any issue because it is going beneath the equipment. See, it's going under the component, so not the equipment, under the component, so we will not have any issues at that point, right? So this closing the video. You can also try this at your home. If you have a laptop with you, you can try. There are also other platforms which you can explore, right? So like this you can create any complicated circuit. You can create your own ideas. You can test them in the lab, and after testing you can create a design like this, and you can create a PCB, and they also allow you to order the PCB through this website. So they will what they will do is they will actually print and give the circuit board along with the components. They charge minimally. Let's see, this is fabrication. Yeah. So when I do this, when I consider make this as a fabrication file, okay, let us see. Okay. When I generate, this is very important, the Gerber file. This is what the PCB printing companies will ask. Just when I say generate Gerber, it will generate Gerber file. It will ask for a location. I'm going to give a location somewhere. Somewhere here. Yes. Now it is stored. We can directly order the PCB as well. Okay, so they will ask for some information. It will take you to the website where you have to log in and order, so that they will print and give it us in abroad. They also have some people, some connection in India also, so they will print everything and give. So in a simple compact PCB, you will have your amplifier design. Right? So keep practicing this, so you'll get used to all the tools and the library items. You will start building a lot more like this.